Hello again, everybody. Um, I'm gonna refill my water glass. Hold music. Just a minute. Getting a nice sunset over Puget Sound. All right. Now, I thought we had our mayor going still. Yeah, we were working earlier in the day, trying to, uh, yeah, got a branch going. Okay. This must be, all right, good. Checking for the handoff mail. Good, thank you. Um, okay. Yep. More mail backlog. Backup artifact dir missing. It says spam, but maybe we need to fix this. Okay. Yeah, worth fixing at the source. I agree. Yeah, session nudge. There you go. We might want to give it more specific. Like we've got GC this and that. Um, GC agents. GC, maybe we need to add GC session stuff. Okay. This prompt might be out of date too. Like I think that it's the basic one from the tutorial city. Maybe we should look at newer ones and see if there's a lot of stuff we could include here. We can we could enable this backup. That's fine. Okay, the Smith is running. This is an interesting interpretation of Zero framework cognition. Yeah, definitely of the opinion that we should just do some DOLT backups. Sure. Uh, yeah. Let's refactor it as the Smith suggested, since it seems to split along two agents paired, two agents parters. We haven't designed it. Let's design. If there are open design questions, we can discuss. All right, great. Cool. Yeah, earlier today we finished this Shugaku puzzle. Did we look up what Shugaku means? Do we know things? Oh, this is a whole phrase. Hopefully it doesn't say anything dirty because we're about to go look it up in Google Translate. That's a bit much for me to retype. A night on the school trip. Oh, okay. That's interesting. So this is um, the night part. Okay. Here we've got Shugaku. That's the school part, I suppose. Ryoko. That would be the trip part. School trip night is a way to put that. That's sort of the this is more idiomatic probably. And the way that it's capitalized suggests that it might be like the title of some work. Just curious here. Is it a manga? Yep, sure enough. There is such a manga. Okay. We couldn't figure this out. We tried to trust the Claude Code tab, and it's like we can't win for losing. Um, we can't open the JSON lock. I guess we could look at it. Maybe I should. If there's anything private about this, then I don't want to, you know, share it with everybody. That's funny. Why isn't it letting me read write this? It's not letting me look at the directory for some reason. Hmm. Oh, you know what? Maybe I don't have execute permission and I need it. Yeah, yeah. I think that was the problem. I changed it to 700 instead of, or 600 instead of 700. Let's do that. Does that make sense? Okay, that ought to do it. And now, okay, now I should be able to look at the JSON lock. You know what? Maybe it's because I gave the directory bad permissions. I looked at it, it's just an empty file. Um, let's try this again. Must be fully qualified to tap. Was it not that one? Okay, maybe this will work now. Okay, yeah, it was just that. Okay, check. Yeah, once I fixed the permissions on the homebrew directory, then it was able to go through and trust things. Okay, cool. It looks like we might want to garbage collect HQ also. Okay, looks like we're on exactly the same page. A little race to that observation. Okay. I'm not sure why this is a night at the school trip. It might refer to like sleeping in futons. I don't know. I can't guess. Okay. Shikaku. Divide by box. Okay, so this one we have in Simon Tatham. It's rectangles. And I'm pretty sure Yeah, it's credited, yeah. Shikaku. The quality of puzzle design is not quite as good as handcrafted puzzles would be, because they can make pictures and things like that. I think we played this one on stream too, but the basic idea is that we, if you add up all the numbers and all of these numbers, then you'll get exactly the number of squares in the grid. And we need to construct rectangles that cover the grid exactly, and that include one number per grid in a rectangle of that size. So there are some easy early clues that we can do. Then we have to start looking for things like this, where there's no other option but to put a 6 here. And so then that causes this sort of chain reaction. But yeah, there's a bit of ambiguity about. So for instance, this doesn't work because if you look to the left of this, we have to get 10 cells into an area that only actually has 9 cells. So see, we have a 6 and a 4 in an area that only has 9 cells. So that's not the right answer. It's got to be like the other way around. It might be like it would be like this if it didn't squeeze that 6 there. See, there's no way to get this big enough. We'll have to do it like this and like this and like this. You can see things kind of cascading from here. We need to get into 8. This is the only way to do it. There you go. So that's Shikaku / rectangles. Yeah, this one's a more interesting example, probably. Slitherlink, our old friend. We've done so many Slitherlinks on here. It's called Loopy in Simon Tatham's puzzles. And this is the 2x2. This is the sort of square version. But as you can imagine, there are a lot of interesting versions. We've talked about this like many, many, many times. The ones that are most interesting, in my opinion, are ones where the pattern's kind of regular. So like uh this one's kind of, this is sort of the one of the worst ones in my opinion, because you got to count. Well, these are dodecagons, so I'm sure I'll have to take all of these to get to 11. But how many is that exactly? 4, 5, 6, 7, 8, 9. It's just very tedious to do all the counting and stuff. And so it's a lot better if you come over here and everything is 5, or come over to even kites. Everything is up to 4. They're all the same shape even, but they kind of interact in some interesting ways. Uh, yeah, there are lots more examples. What's Kagome again? I don't totally remember. Oh, okay, hexagons and triangles. This isn't so bad, but yeah, you can see that like the fun of this is like learning patterns, right? Learning rules that apply to multiple situations, and they interact in a kind of interesting way. All right, 1, 2, 3, 4. We need this one. So yeah, I'm not a huge fan of triangles. They're a little bit too simple, because it's either 1 or 2, or maybe 0. Anyway, you get the idea. We know Slitherlink so well. It has lots. It goes by lots of names. Stone. I don't know if I remember. Oh, right. This is the one. I think we did do this one. Um, when all the stones fall down, then they must cover the lower half of the grid completely. A number indicates how many must be blackened. Without a number, we have to pick at least one. Within a region, they have to form an orthogonally connected area. Then when we drop them all down, they're going to Tetris-like into the bottom half. I feel like we did one of these on stream. I don't think it was Did we do this one, this particular one? I don't know. We'll see. I think we might have picked it up when we did the other Nikori puzzles, perhaps. So like one thing that we're thinking about is like in each of these first two columns, we're gonna have to get because they're divided into squares, right? And we're going to fill exactly half of this thing. Then no matter what, we're going to color in exactly 6 squares in this whole column. And same for this one. And so you can kind of, for this one, you could imagine there's a little, oops, that's not very right. That's so small. You could imagine there's a little 2 written in here. And down here, there's a little 2 written in here, right? Because implicitly, right, like we'll color in one of these, we'll color in 3 of these. And so we've got to have 2 more to finish off this column. And there's a sort of interesting Tetrisy rule about overhangs as well, right? Like we sort of can't color in these and then a couple up here because when they fall down, they're all going to sort of balance on top of this stone. And they sort of need to tuck under. So that kind of thing. So we're going to get definitely 2 in one of these columns. And we've got to get 1 out of the remaining column. And we also have this rule that we can't do we can't leave spaces. So like this is illegal. And so would this be illegal? Okay. Maybe this just doesn't have a lot of pixels, I guess. Okay. We're seeing the pixels, maybe. Where can we start from here? Are there any other rules that we're working with, really? Black cells must not be orthogonally adjacent across borders. So I think we will be able to learn something from that. Like, for instance, if we colored both of these on this 3, then both of these would be empty for this 2. We have to pick these 2. And then we'd be in a bit of a pickle because let me show you what that hypothetical world looks like. Say that these are colored in, these can't be colored in, and these have to be colored in. Just following rules here a little bit. Okay, so here, for example, we Tetris these pieces down, and then there's this overhang, right, where we've completed this one. We've got 2 in this column, but they don't fall all the way down. They get stuck here because this is treated as a unit, like this. And this is treated as a unit. And then we'd have to put a third one in this column to fall down somewhere, but it would fall down on top of this one. So we just proved a hypothesis that we can't put both of these as stones. That means we have to put both of these as stones. We also can't create an overhang because nothing could get under this to complete the Tetrising. So we have to put them like this. So now we're going to, in some way, have 1 in this column and 2 in this column. There's different ways to do that, right? Like we could put 2 across like this and 1 down here, and they'll all Tetris down into place. we could put 2 in here and 1 in here, and they would Tetris down into place. Certainly we're going to, in this second square over here, we're going to have to fill in this one because the diagonal move is illegal. But this one won't be filled in and this one won't be filled in. The diagonal move is illegal, so we have to fill in this one. It's illegal, so we'll have to fill in this one. This one. Okay. There we go. So we can't do the solution where there's 2 up and down right here. We can't do the solution where there's 2 across right here. We certainly can't do 2 across here. We can do 1, and we don't have to be sure which one it is. It can't be this one. Oh, we definitely can't do 2 here then. That's interesting. So it's either going to be 2 this way, or 2 this way, or 2 this way. And it's going to be either here or here. Okay, that's kind of interesting. We can do all 3 of these across. We can't do this one sideways and then these 2 up and down. We could do all 3 of them sideways. Or we can do 2 of these up and down. And then this one sideways. Is there a way to do this? I don't think so. Look what happens if we do this. Yep, it doesn't work. There's 4 on one side and 2 on the other. So we certainly have to do this. This is interesting too, because we have to put these 2 stones here and here to complete this column. And then we can infer that this would be illegal, and we can't play this one because it's inside of the region. They have to be 1 stone. There we go. Okay. We synced a full clean point in time copy. That's cool. GC Jolt compact skipped HQ. Cool. It has some 5x5 puzzles. Great. Great. Okay. It took care of a lot of stuff. Generator runs in browser. Viewer stays a static shareable artifact. I see. Okay. Yes. The ultimate goal for the puzzle generator is to provide on-demand puzzle generation in an on-device context, such as a phone. So I think the static HTML is serving purpose for testing. And road shows to me the customer stand-in, but it would be better to support that case by packaging our own library. Help me decide what's on path. Yeah. Okay. Tetrising. Ah, this eliminated a stone for us. Okay, and so now we're forced into this. And this eliminated a stone or a rock pebble. And sort of trivialize the rest of the puzzle. There we go. Yeah, that's it. So we've got 3, 4, 1, 2, 5, 3, 4, 6, 2, 5, 6. 3, 4, 1, 2, 5, 3, 4, 6, 2, 5, 6. Yep. 1, 3, 4, 1, 2, 5, 6. 1, 3, 4, 1, 2, 5, 6. I didn't zero index them, but yep, that's their solution. Stone. What else can we say about Sudoku? All right. There's many variants of this, which I think is a reason to study Sudoku, even if we're already familiar. It says this is a trivial one. We've got the numbers 1 through 9, once per row and column, and once per each number in the grid here. Using the given information, we can infer all of the rest of the numbers in this puzzle. And often, what we want to do is eliminate possibilities. So here, I've noted that in the rest of this row, we only have the numbers 1, 2, 6, and 4. And 6 and 4 already appear in this region. So only 1 and 2 can fit here. Ah, here's an even better one. 1 can't be in any of these because it's already in this region. So this has to be 1. These guys have to be 2, 6, and 4. I can see there's a 2 down there. And we can kind of go on like this. But we're always kind of looking for the next interesting inference. We're looking for kind of density of numbers as well. Let's see, 2, 4, 9, 2, 4, 1, 6. And so, I mean, this one is supposed to be easy. 2, 4, 6. And I know that purists, even Nikori has a statement that says, hey, you don't really want these, do you? Just made by a computer. You know, these aren't very authored. They don't have that je ne sais quoi of human creation, the kind of creativity that allows you to get inside of the puzzle writer's mind and follow their train of thought in a sense, and the delight that you have when everything finally clicks in. I don't really solve these that way, I wouldn't say. No. I do a lot of this, and this is pretty, of all of the puzzle types that I do, this is the one that's the closest to like the pure constraint satisfaction approach that a computer might take. Now, I'll gratefully take an insight if I can find one. For instance, this can only be 9. I determine this from like looking at this column and this region. 1, 4, 6. Huh? The 1s are taken. The 6 is taken. Right? But I've done hard versions of this puzzle where it would have been really hard to like hunt around for the inference, and instead we're kind of brute forcing it. And that's sort of what these numbers are about. You can see patterns in the numbers and see like certain things are filled in or covered already. And you can kind of keep reducing the puzzle until you get to some insight. But you might even have to, do some hypothesis testing, like what happens if I pick 4 for this and I follow it through. And then in Simon Tatham, we've got undo moves. We can backtrack if we can remember where our hypothesis started. Um, certainly, like hypothesis flagging or checkpointing would be a feature that I haven't seen a whole lot. This 4 is in a column. But yeah, it would be super suitable for some of the more complicated versions of these puzzles. But it's not something that you really do with pen and paper. It's like a purist would, again, like turn up. It's not like race legal for the puzzle Grand Prix, and maybe I'm cheating myself a little bit by not using my brain like other people would here. But it's hard to say, right? Like you kind of find your own fun, and if I enjoy the tedious process of filling in tiny numbers and slowly eliminating them, then that's kind of my fun, I guess. Hmm. I mean, again, this is trivial, and I haven't picked a very hard example. There we go. We're done. But yeah, they have a lot of interesting variants, like along the diagonal. We've got some jigsaws that have different shaped regions, but then all the same rules apply, and those I think are pretty cool. Um, we've got jigsaw X. There we go. So we have to pay attention to the rows, columns, diagonals, and jigsaw regions. And so one thing that's interesting about this is that the more sort of variants and things you pile on, the less number clues you have to put in the puzzle. Kind of fun. You see there are no 1s in any of this. I think, is that the only one missing? 2, 3, 4, 5, 6, 7, 8, 9. Yeah, but no 1s. Yeah, and you can kind of do that stuff. I think. Oh, killer digit sums. And there's symmetry of clues. We can pick the difficulty. It's probably taking a while to generate this for us. Okay, so digit sums. So this is like the rectangles are telling us, well, these two have to add to 15, so it's either 9 and 6 or 7 and 8. Yeah, those are kind of fun too as well. So yeah, you can see there could be a lot of weird stuff going on. Anyway, Sudoku. Uh, Sukoro. Enter numbers from 1 to 4. How many cells with numbers are orthogonally adjacent to this cell? The same numbers are not next to each other, and they must form a single orthogonally contiguous area. That seems new. there are some that have groups of numbers, but I don't recall seeing this one before. Okay. Does the generator solver have node-only dependencies? Okay. A portable on-device generator library. And then no server, runs in plain JS. The only node bits are just some parsing, process exit, and output. The core solver is already node free. There we go. Lift this into a pure ECMAScript, I assume, module. Keep the CLI as a node adapter on top. Cool. Yeah, great. So we should start moving toward this. Yeah, of course, we want to sort of cross-device compatibility is good to have. So if we can build something that'll work with minimal work up into Android and iOS. Mostly I've worked in a context where we're either making web views or we're doing cross compilation, that kind of thing. And native specific features are sometimes necessary for performance, but generally that's not how you want to do your whole thing. Great. Sounds like a good plan. Let's yeah, write it up in. Let's write it up. Let's capture it in the leads if it's helpful. If it's helpful, making a road to mobile prototype. Making road to modal. I'm trying to sort of conceptualize here. Making road to modal prototype and epic and starting to diagram that seems like a good idea. Diagram, lay that out, lay out that, task graph if you want. Okay. What did we say was next? Sukuro? Sukoro. Okie dokie. Okay. We can't have the same number next to each other. We're saying how many numbers we have orthogonally to us. Is that right? How many numbers are orthogonally adjacent, but not the same number? Okay. Okay, I think we're gonna get it, and they're all connected. So this one can't be filled because this one already has 3 numbers orthogonally adjacent to it. Same with these, because of this too. We don't really have to check things off. And we'd like to be able to say that something belongs here. It's either a 2 or a 4. Maybe we're doing it like this, like Sudoku. And something belongs here. It's either a 1, 2, or a 4. What's interesting about this is that the only thing that can fit here is a 1, right? Because there's a dot below it and there's one number next to it. So that has to be a 1. It's not just because of um, the fact that it's different from 3 and 1. It's that there can only be so many numbers next to it. There can't be any 4s on the edge because there's only 3 adjacent numbers to each edge. So this has got to be a 2. So proud that I found my eraser color. Okay. And this one's kind of checked off, and these ones are kind of checked. I don't know. I don't even think checking off is helping me keep track of anything. This one. Okay. Yeah, I think now that we're sort of paying attention to this number thing, um, there has to be a number next to here because we have to fulfill this 2. It can't be 2, but there are already at least 2 things next to it, so it's got to be a 3. There's got to be something down here. Now this thing is satisfied. Look what happens if we put a 1 here. We'll put a dot here, and then we'll cut off all of this from the rest of the puzzle. So this definitely can't be a 1. It can't be a 3 because there's an empty hole here. We've eliminated everything but 2. There has to be something here. Also, not just for cutoff, but also to satisfy this 2. It can only be the numbers 1 through 3, and the other ones are taken. There has to be something. This one is satisfied. There has to be something here. It's a 2. It has 2 neighbors already. And it's satisfied. Certainly can't put a 1 here. That would isolate this as a 1 island. So there's nothing here. That was kind of interesting. This one's already satisfied. We could put something here, like a 1, and it would connect up to this guy. And then it would have to sort of shoot out this way. Both of these have to be filled in for both of these. That means one of these is going to be filled in, but not both. If there's anything here, it's a 2. It's either a 2 or nothing. I guess we could lay that down here. If this were a 2, then this would be cut off here. And of course, this would be cut off here. This would be finished. I should have picked a different hypothesis color, but I'm sort of using the smaller in the corners to hit that. Okay, great. Okay, we've got the roadmap document for mobile prototype. Cool. This has felt more productive. What model are we on? 4.8. Okay. Maybe it just got better from 4.7 to 4.8. It's a subtle thing, but I think if you're paying a lot of attention to it, you know, maybe you'll see stuff like that. Do we have any more rules we're supposed to be taking advantage of? I don't think so. Numbers from 1 to 4. How many cells with numbers are orthogonally adjacent? Same numbers, not orthogonally adjacent. And they have to form a contiguous area. We haven't really been taking too much advantage of same cells can't be adjacent. So like if there is something here, then it has to be a 3 or a 4. But there could be nothing too. And see, here we run into this problem where I had this hypothesis running with this corner, and now I have this other one that's sort of disconnected from this. If this were nothing, then this has to be something. It can either be 1 or a 2. If it's 1, there has to be nothing here. This has to continue. And if there's a 2, then there has to be a 3 or a 4 here. This stuff gets cut off, which is fine. Okay. Let's see, we can backtrack to there. If this is empty, then this has to have something to it. I'm trying to figure out the best way to proceed. I feel like it has something to do with start a hypothesis where, say, this is empty and this has to be filled with something. Maybe I'll put this slash here. Certainly all of these have to be filled with something. Oh, wait. Well, we know this number then. This number, if it has to be filled with something, it's got to be a 2. Right, there's no other choice. If this number is filled with something, can it be a 2? Let's try that for a second. It looks like this. We could put another 2 here and kind of get out this way. We can't put a 3 here, but we could, and we can't put a 2 here. We couldn't put a 4 here or a 1 here. So we'd have to put nothing here. We have to put 2 here or we'll cut off the island. We can't put a 1 here, which would also cut off the island. So we can't put a 2 for dupes, so we'd have to put a 3. We'd have to put a 2 here. And then this would happen. Yeah, so this is contradiction. So, and the contradiction started when we stuck a 2 here. So we can't do that. Can't put a 3, we can't put a 1. It's a 4. I think it's sort of learning how to use molecules, cooking, formulas, all that stuff. Okay. We can't make this a 1 because there has to be something in this corner, and putting this as 1 would make this empty. So it has to be 2. We can't make this a 2 or a 1. We are stuck with 3. Here it's starting to ease off a little bit. We can't have a 3 here. We have to have a 2 here. If we had a 1, that wouldn't work for this 4. So 2 is the only thing left. We're going to have something here, so this is going to be empty. We can't choose 2 or 4. We can't choose 1 because there are 2 neighbors. Therefore, this is a 3. This one can't be 3 or 2. It can be nothing, or it can be 4. If it's nothing, then this one has to be filled in. Oops. I'm using the wrong nomenclature here. The wrong notation? Wrong notation here. This one would have to have some neighbors, but it can't have either 3 or 2. So this can't be right. This one has to be a 4. This one is not filled in. This. It's cut off. If this is a 1, that's not out of the question. We'll kind of escape out this way. I'm kind of enjoying this puzzle. I find since we're looking for inferences and we're not filling in like too many of these like hypotheses, like, oh, it's 1 or 2, or could it be 3? There aren't that many possibilities. Like in Sudoku, you have 9 possibilities per square, and you whittle them down, but in this kind of thing, that's not happening. If we do connect up these, then this is going to be empty, and there's got to be something here. It would take a 3 or a 4 to connect these together. This definitely can't be a 1, and this can't be a 1. So it would cut off those islands. So one of these is going to have to be like a 3 or even a 4 up here. Okay, how are we doing? Yep. We could read this. Maybe it will expand this acronym, WASM. I think I know what that means. No, maybe not. WebAssembly. Okay, gotcha. So this is like, no matter what, we'll be able to get something into the browser that's working. Yeah, let's take a look. There's a mermaid diagram and everything. Shouldn't I be? I guess I should open this in my browser. Oh, it's not it's not doing the mermaid chart. Um, I guess I need a markdown viewer. Uh, an offline one. Linux. MarkText. Sure. We can just go get it. Is it in Homebrew? Did I just look here? I'm just gonna, even though it says it's Mac. Oh, why did they put the hyphen in there? Oh, dope. Ah, if it's an apt, then maybe we should be looking here. Come on. Do you ever get copyrighted songs stuck in your head? There we are. Okay, well that's happening. Oh, that's interesting. Okay, I don't know what that was from. Interesting. Okay. Um, you could argue that this is in the lane of the presenter, perhaps. We could talk about whether we need a new agent that's specifically doing this mobile work, that kind of thing. Yeah, hold it until Smith defines the library API. I agree on holding the work until Smith defines the API. I think you can set such dependencies in the beads so it won't show up in presenter's work query until it's ready. Should we have an agent beyond presenter work on the mobile section on any mobile specific tasks or expand the charter of presenter? Or something else. Is my viewer ready yet? Okay. This will be in our app list now, MarkText. It's the one. Oh, sick. All right. Architecture. So we'll have the solver core, the generator solver plus solver library, the CLI adapter, the HTML viewer, and then the phone app roadmap. Let's no, I kind of just want to zoom in. How do I do that? Okay, that's working. Control roll. Okay, the Smith extracts the portable library. The viewer consumes as the performance harness. We could measure how fast it is with performance metrics. We can probably, don't want to delete. Is there a way to hide this again? Okay, I just have to click off. Okay, we might be able to get through, look at React Native, progressive web app, or web view. I know this must be kind of tiny to read. It's a little tiny for me too. Let's see if we can. Where's the diagram? Where'd my diagram go? Okay, I genuinely don't know yet. Like, what am I looking for? Magnifying glass? Screen magnifier? Do I not already have something like that? Mag? I don't think so. All right. Let's try this one. Small and simple. Where is it? Why isn't it opening? How do I use it? Okay. Not getting it yet. Uh, do I have to hit some button or something? Not what I was trying to hit. Control? Alt? Okie dokie. Maybe the README will tell me how to use it. No? Okay, I'm giving it about, how many more seconds can I give this? Oh, I'll do one last ditch effort. How to install. It shows the area around the mouse pointer. Oh, you know what? Maybe the problem is this VM. The VM thing. It's not detecting the mouse pointer. All right, let's look for one more. Am I getting weird performance issues? No? I don't think so. This is all for your benefit, you know. We're investing right now in the future of this stream. I don't know why that started locking up so much, but if it's unresponsive, then it gets the boot. Try this one. This is Xzoom. I think they're both having the same issue. Something to do with. There's a built-in screen magnifier. Okay, in Dconf. I mean, this is kind of old, right? It's from 6 years ago, but okay. I guess that didn't work out. We're gonna uninstall Magnus also. Not Magnus's fault, it's just not working inside the VM, I guess. Okay. This is better. This is not from a trusted source, the GNOME project. If I don't trust the GNOME project, I'm pretty hosed. Okay. Okie dokie. Go to org GNOME desktop A11Y. Well, that might be that anything that looks version numbered from 5 years ago, we're gonna be suspicious of. Org GNOME desktop seems safe. Okay, A11. Oh, accessibility. A11Y. Applications. Screen magnifier enabled. Woo! All right. Okay. Let's see. We don't like the default one, which fills the whole screen. There are many preference options. Magnifier. Here we go. Okay. Lens mode. Magnification factor. Anywhere from 0.1 to 32. Let's try 3. Oops. Why didn't it let me? Did I have to click on this first? There we go. Okay. Wow. Okay, mouse tracking. Determine the position of the magnified mouse image within the magnified view and how it reacts to system mouse movement. Okay, so I think what this is about has to do with the position of the magnified mouse in the zoom region is proportionally the same as the position of the system mouse on screen. So it's going to make the cursor look bigger, I think, too. Okay, how do I turn on? Let's see here, scroll at edges. They've got turned on. So crosshairs they've got turned on. Okay. Crosshair opacity, etc. Then what if I have a I thought there was a way to make it so that it wasn't filling the whole screen. Isn't that what he said? Focus tracking. No. Screen position. Let's say let's start with the right half. Let's see. So yeah, we're not often using the right half. We might be able to get away with magnifying things into the right half. Can I do a hotkey to enable the screen magnifier? It's giving me Windows. I'm sure I can. I saw something about super alt equals. There we go. Super alt 8. Okay. This isn't bad at all. Ah. Okay. Cool. This was the page I needed, I guess. At least with Dconf editor, we can go through and we can figure out all the different settings that we want and how to configure it. So that was helpful, I think. All right, where is our, so we got MarkText. Here we go. Super alt equals. Now you can read this with me. First, the Smith extracts the portable library. The presenter makes a viewer that consumes and does a performance harness. We check if it goes fast enough on device. If it is, then we can just go with the JavaScript library. Otherwise, we're going to have to do some WebAssembly. For the phone target, we're going to have to do some sort of integration with React Native, the progressive web app, and then we'll have a mobile prototype. That's the roadmap. Cool. Now that we've got this figured out, we can read the rest of the document. And, yeah, we can probably shrink this text down a little bit too, because we're powerful now. Yeah. Okay. Hope you're all enjoying this as much as I am. Okay. Yeah. And this is more or less what it says up there. Okay. Cool. Well, we'll probably use that markdown viewer again in the future. We don't need to save anything. It's nice that it made diagrams for us and everything. We can wait on the mobile till we have got said. Okay. Cool. A lot of delays to keep the human in the loop. All right. Well, that was cool. I'm glad that we have Dconf editor. I'm glad that we have a magnifier. Oops. I'm not glad that I used the scroll wheel inside of Tmux. Not cool. Or possibly inside of Claude Code, I guess. I don't know exactly which one is capturing the scroll wheel, but okie dokie. I don't need that. Did I accidentally close my tab for Yanko? That would make me happy. Maybe, oh, there we go. I opened our markdown file inside of that. So now we can get rid of all of this stuff. Okay, cool. Super Alt 8. I'll try to remember that too. Okay, we're sort of done with App Store for now. Okay, we didn't quite finish our puzzle. All right, it's still working hard. Certainly this, if this is filled in, it's got to be a 3 or a 4. Yeah, because there's going to be something here. So it's 3, 4, or nothing. I don't feel like there's an inference that we can make there yet. This one can't be 1. It can be 2 or nothing. Similar to this one, 2 or nothing. If it is 2, then this one would have to be 3. I guess this is worth pursuing a little bit. Oh, oops. I didn't notice that we got on white somehow. Okay. Right. This can be 2 or nothing. 2, nothing. Let's pursue the 2 side. If 2, then this one can't be a 2 or a 4. It has to be a 3. Then this one can't be a 1, 2, or 3. It would have to be a 4. This one would be done. Cut off right there. This one would be a 1 or nothing. This one would be satisfied. It would cut off right there. So we certainly couldn't do anything that would cut this off. Couldn't do a 1. We'd be forced to make it a 2. If it were a 1, then we would be able to, we would have cut off all of this right here. And this one, in turn, to connect up would have to be a 3 or a 4. So far, this isn't like the worst. We're sort of looking for a contradiction, and I don't think we're really finding one yet. If this were this can't be 2. Like I said, it'd have to be 3 or 4. We would definitely have to have something here to get to this sort of cluster over here. In this world, this would definitely have to be a, well, it doesn't have to be filled in. If it's filled in, then it's a 2. We definitely have to have something filled in here as well. One of these has to be filled in. We already knew this one had to be at least 3 or 4. I mean, it seems like this path is kind of working, but I don't see anything that's sort of forcing us into like making an incremental observation. If we try the nothing path, this could be as small as 1 over here, as long as this sort of keeps escaping. This one is either 3 or nothing, because it can't be a 2, it can't be a 1, because that would sort of cut off this whole island. Let's try this for a little bit. If this is nothing, then this can't be a 2 or a 1. It's got to be a 3. It can't be next to a 3 or a 1. So this would have to be a nothing. No, it can't be a nothing. It'll have to be a 2. Then I'm using this for like to represent nothing. Nothing's there. Not great. This one can't be a 4 then. It can't be a 3. So it has to be a 2. This would be nothing. It'd have to be a 2. This would be nothing. And then this can't be a 2. It would be like a nexus. It could like join all these together. So this isn't so bad. I mean, we would be able to do this. Now let's try the other side. This is a 3. And this is nothing. This can't be a 3. It could be a 1, probably. As long as we go out somewhere out here. Not seeing a fast inference there either. This can't be a 4. Right, we did this one already. 2 or nothing. If it is a 2, kind of stuck here, here. We certainly can't pick 2 right here. That would cut off everything. It could be 3. Yeah, again, not seeing the fast inference. Hmm. We seem to be reaching the sort of Sudoku level now where we're looking for the hypothesis, we're looking for the answer. Okay. All right. Smith already built this library. That's great. Look at the dependencies. Cool. There's mail flying around, but it seems like, yeah, we're not quite to the point where all of our workers are inquiring about the progress of the workflow and whether there's anything on their board. We're still like dispatching. The mayor is like the workflow engine. Don't stand up a mobile department yet, but plan to in phase 3. The work decomposed by concern. Absolutely right. Concerns already have homes. Okay. Genuinely outside of every current charter. Good. They're different concerns. Conway's Law. No, I definitely, yeah. definitely prefer this. We don't have this. Yeah. Okay. Mm. Yes. We can absolutely. We can. Yes. Happy to defer this charter call until it is ripe. It seems like we could model that with another feed with a dependency. Hydration at 90 minutes. Just trying to remember if I remember how to do this. Then we've got this. This is like 1-to-1, isn't it? It's kind of funny that we can move the text around. Yeah. Cool. All right. Oh no. This, are we getting 529s? Not on my account, I don't think. I don't think our usage of Claude has been super heavy. Let's try that again. I don't know why that WordPress was failing after all of our other busy stuff. It's not. Yes, this is in our history. Elevated errors for 4.8 at 5:08 UTC, which is 15 minutes ago. Right? Yeah. Okay. Well, maybe we're getting a hint that we need to leave it here. Okay. Well, tell you what, I guess for you puzzle fans, we'll just finish out this puzzle and then we'll try one more time. And if we're done, we're done. Okay. Let's try a probe that we haven't tried yet, which is sort of like what if this is empty? Well, we'd know that we need to help this get out with some number. And we'd need to get out here and here. Well, this would be a 2. Then here. This would be, if this were a 2, then this would have to be a 3. And this would have to be a 1. This definitely couldn't be a 1 or a 2. It would be a 3 or a 4. Okay. Uh-huh. Option B, this is some number. This one is satisfied, so this is empty. This is empty because it's isolated from all the rest of the numbers. We don't know how big this is, but it's max 3. This number over here is max 2. 2 or 1. If it were a 1, this would have to be a 3, and we'd have to scoot over here. I don't think this works because, well, if this were a 1, this can't be a 1. It would look like 1, 3. If this were a 1, then this would be empty. And then this one would have to be, couldn't be a 2 or a 3 or a 4. So this can't be a 1. It kind of has to be a 2 or a nothing. If it's a nothing, then this would be a 2. This is sort of free to do whatever. If this were a 2, then this would obviously not be a 2, it'd have to be a 3. Yeah. This were a 3 and this were a 2. And this would have to be, well, it wouldn't, right. We'd have to have a number here. And it would have to be at least a 3. So it would have to be a 4. But if this were a 2 and this were empty, then this would have to be at least a 2, so it would have to be a 3 or a 4 again. I feel like we're really close, like we're on top of some insight. But I don't think that quite did it. Maybe we haven't spent enough time with this square right here. Our options are nothing, 3, and 4. If this is 4, then this will be filled in and this is going to be empty. In 2 of these cases, this square is empty. This is 4, then this has got to be a 2. If this is 3, this has to be a 2 or a nothing. Nothing or a 2. The reason I'm saying that is that we can't make it a 3 and it has at most 3 neighbors. We knew about nothing or 2 before. That would make this one empty for the 2 case. If this one, I guess it's actually empty in both cases because if this has a number above it, then it's satisfied. In those cases, we're forcing a 2 over here. And then we need another one over here that's at least 2. It's got to be a 3. That would satisfy this one on the left. And we have cut off this little island here in all cases for this. Here we go. So the real inference here is this definitely can't be filled in. We have the same problem if we put the 1 here. Not quite, because it can kind of curl up around here. Yeah, this thing being satisfied is causing issues. What if this is cut off here? We can go down this way. We can't go down this way. The reason I'm saying that is that if this were cut off here, then we'd want to put a neighbor here. It can't be a 2. I guess it would have to be a 3. It can't be a 1, certainly. That would like cut off all of this in every direction. It could be a 4 even. I guess it would have to be a 3 or a 4. Maybe that's not super helpful inference. We waited 10 minutes. Let's see if we can get it to answer us. This is the only problem with the setup I've got right now. I'm only paying for one of these agents, so if I were paying for a bunch of other ones, then maybe I'd have a backup when there's an outage. Ah, a perf blocker. Interesting. Maybe it has something to do with the way that how long it takes to generate a puzzle. Certainly, I would think it should be super fast. It's like pure CPU. It shouldn't require too much exploring. And so we might need to look up some techniques to do it well. It might be that going from a solution and then knocking out clues isn't that fast. Or it might be specific to the sort of the prototype we're working with. But in any case, we'd want to get it super, super clean on a very typical puzzle before we tried to innovate and push the envelope. Okay. This can't be. Now that we have this dot, maybe we should revisit some of our other experiments, like 2 dot dot dot. We definitely have to get out of here. We can't put a 1. We'll cut off the rest of the puzzle. So we've got to put a 3 or a 4 here. can turn to the other side of our equation here, which is, what if there were a dot here? There'd certainly have to be something here. Here there would be a 1. Not that it totally matters. This would be a 2 or a 3. If there were something here, sorry, I'm working through the possibilities of having a 2 here and having a 3 here, and then this would get cut off. This would extend this way, and this would have this neighbor. It's a lot to kind of keep in your head. Say that this were cut off right here. What would we believe? We'd have something here, nothing here. We definitely have to have something here and here. Nothing here. And we would have something here for sure. Now, we actually know a lot of these numbers because we know how many neighbors they have. This one has 2 neighbors. This one has 4 neighbors. This one has 2 neighbors. And this one has at least 2, but it's got to add some more. So no heavy contradiction here. Let's try the other angle. Like this is a number. Then this also has to be a number because it's a neighbor. This can't be a number. So we actually have an inference here because in both cases, there is no number, there is a number. This is empty. And then this one is still 2. Okay, well that's helpful. So we're learning lots of stuff here. Okay. Oh wait, but now this one can't be. So this one has to be something. And this one can't be something. Maybe there was a contradiction there that we didn't quite parse our way through. If this were a 3, it would be cut off from the rest of the puzzle. This can't be a 1. It'd be cut off from the rest of the puzzle. There we go. All right. Real progress. Okay. Well, okay. This is saying that we can't, it's taking seconds to minutes to generate these small puzzles. I know that's not exactly the case, right? like I have an existence proof right here. You know? Um, Here, let's see how fast. It's like instantaneous. I can't click this fast. Um, oh, clearly there's something wrong. Um, I'm more inclined to push on performance. Maybe the algorithm we are using is wrong. Um, uh, is wrong or naive? We could study published literature on puzzle generation algorithms. I mean, again, we're not looking to rip people off or steal their code. The point of this is to understand the problem deeply in a general way and then apply it to new forms. Ten by 10 normal. See, 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000. This might take a while. About 12 seconds though. Have you ever looked at it, marveled at its beauty? I mean, if you like Slitherlinks, then I don't know. I defy you to come up with a human puzzle this fast that what it lacks in sort of creativity and how do well the je ne sais quoi, that human artisme, it's making up for in we're just going to see a whole lot of situations here across the board, and it's going to have made something that's big enough that when all of the different threads of the sub problems of this thing come together, um, it's really going to be, um, it starts to get like NP complete kind of stuff, right? Like, you have to you have to say, well, if it starts looking like 3SAT, in other words, right? Like all of if this is this way and that is that way, it's like they're all little switches that are flipping all across the puzzle, and the longer you play this game, the more that's gonna feel obvious. Oops. We can see how fast I can clear this. It's certainly taking more than 10 seconds to clear it, right? Write a maze in 2 minutes that you can't solve in 1 minute. Um, yeah, I mean, This is the kind of thing that if you like this kind of thing, this sort of mass quantity kind of thing, Puzzle Ninja is a good book, published book to find this kind of stuff. Like they have lots of puzzles of this kind, and then they have particularly big ones. Like they're sort of graded by difficulty, and they get larger and larger as you go through. For that sort of reason, right? Like the interest of them is magnified when they get bigger and they show off larger and larger patterns, like this one. You can kind of see this two radiating outward. It's kind of cute. Uh, Gotta be this one. This one. See, I'm not sure right now whether this half connects across to this half or not. There's a lot of little things like that. All right. But yeah, I've never felt really shy about allowing the computer to look for the algorithmic knowledge that it needs to learn a technique or solve a problem or something like that. And the reason why is that, I consider those all to be fair game, right? Like, none of these algorithms are patented, nor do I believe, you know, from a moral standpoint, they should be able to be patented. Um, and that the kinds of things that we're all learning um, kind of belong to all of us. They're just math. They're our heritage. There are, uh, I think it Roger Penrose who said that God created the integers and left the rest up to us, something like that. But that's kind of how I feel about computer code and computer programming. Interesting one. A puzzle so big that you have to scroll. And like I said, it only took 10, 15 seconds to make. Okay, got another one of these. Do we have any loops forming? Not really, not yet. We do know this one and these ones. We've sort of like been taking the low-hanging fruit, and so everything's going to start getting harder at some point. This is a kind of interesting area down here where we definitely can't pick like these two because that traps this thing in a dead end. It's easier not to have to scroll to undo. How about we do have to enter this side because we can't sort of bypass this corner. At least one of these has to be used, one of these back ones. I'm trying to decide if this is the only way to do it, which I kind of think it might be. Yeah, I think you can satisfy yourself that if this one is clicked, then no matter which other one we take, we're going to isolate something in the back here. Like if this is an L here, these aren't used, and this one is sort of stuck here. Same for this. Now we can do the same sort of trick with this. If this is clicked, then we'll pick one of these and it'll be a dead end. Okay, now we've got 2 on this one and this one. We can't close the loop prematurely over here. Here. Okay, so this is an interesting one. Imagine that we don't click this one. Then we'll have 2 here, and it starts radiating this way, and oh, we hit a 3. So that doesn't work. Gotta take this one. We're gonna pick one of these, so we have to pick the other of the 2. This is a kind of interesting one where it's easy to see the consequences sort of rippling out. If we pick this one, then this forms a continuous line through here. And kind of keep going like that. If we pick this one, then it cuts off and this line goes up this way. This line goes in a completely different direction. Okay. I find stuff like that interesting, where, one simple decision can send it kind of in a completely different direction. Why did I get stuck doing this? Why do I love this so much? Hard to say, right? Okay. I think I'm just trying. I have examples of similar programs generating 30x30 grids in about 12 seconds. We can take that as a that's pretty extreme. That's an extreme size for this puzzle type and would take a long time to solve. What are some of the actual targets? But 10 by 10. But something like 10 by 10 should be within the 2-second range. It's a benchmark. Should be doable. Okay. I don't think I can prevent it from cheating. I can't prevent it from coming here and going. How exactly did they do this? But we're trying to learn the general principles as well. Benchmark. We would like to apply these whatever methods we come up with to a wide swath puzzle types and rule sets. So it's good to make some moves now that are kind of generic and not tied to, not overfit the Slitherlink. Let's do a performance epic. That should make all of our future loops faster. On generating and solving. Okay. All right. Now that we've got it working hard for us, let's return to our white whale here. So one of these can be used, and whichever one we pick, the other one is going to be gone. So we'll come into this thing, and the loop's going to exit on one of these edges, but not both. That's an interesting thing because we have only two edges around this square, and so on the other side, we're going to come from one of these edges, but not both. And we'll kind of come into this side and pick one of these edges and exit. See, a lot of this fun stuff you're just not going to see in a smaller puzzle. You know, we had to have pretty big patterns just to look at it. One of these edges, one of these edges, one of these edges, one of these edges. Okay, I was checking the sort of reverberations around that one. It is sort of a 1 and 2's corner kind of thing, right? But it only really works when we're coming in on one of the edges. Okay, so this one, we can't cut off both of these edges, so we've got to go this way. And now that, finish this. See this S pattern always happening when two threes are next to each other? Inevitable and square Slitherlink. Oops. All right. Getting some motion here. Only one of these, so definitely this one. I have practiced doing some of these inferences from Palisades too. Maybe that's why it is going a little faster. Oops. Not that one. We don't have to press undo either. We can just cycle through the left click and right click. I'll probably start doing that. Solution first generation, and then a fast incremental solver. The current forge is sample and reject. That's not good. Okay. So no wonder it's taking forever to come up with puzzles. It's just making random ones. All right. Okay, we gated this on our performance epic. Great. Now whatever it wants to do, we shall see. Well, I forgot. I've got something else to do tonight. Okay. But it looks like our mayor is well on the way, and hopefully all of our guys are going to be running around and doing their thing. So let's make this our cliffhanger, and hopefully enjoy more interesting puzzles tomorrow. Well, if you've been watching, thanks. Have a good night.